So it says, so if you're seeing my screen, it says eliminate the parameter and obtain the standard form of the rectangular equation. So the hyperbola, I don't even know how to, I guess. I mean, the hyperbola has this form like x minus h squared minus y minus k squared equals 1. Does that sound right? Maybe. There could be some a's and b's also. Yeah. And you get some, maybe some b squared. So like somehow we're supposed to get to this. I mean, obviously, if you kind of move some things around, you get x minus h over a equals secant squared, and then I don't know, it doesn't really matter what letter you use. I'm going to just make a different one, and then you get y minus k over b equals tangent. Oops, it's not squared. Sorry about that. Tangent, some Greek letter. Now, there's a lot of things that you could use. So, but the one that I think comes to mind here is there's this 1 plus, what is it, secant squared equals tangent squared? I got to look this one up. I don't know. I can't remember it. It's in your Trig reference sheet. I might have sent you a few times. It's like the third trig identity.
I think it's 1 plus secant squared.
It is 1 plus tangent squared is what I'm seeing here. Welcome to double check.
Yeah, right.
That's why I look, because I don't remember these. Now, why is that valuable here? Well, you can square both sides, and then you substitute in. Like the way to like kind of like use this though is it becomes secant squared theta minus tangent squared theta equals 1, and then you get back to this form up here on the upper right. But let me just finish this off here. So you get x minus h squared, because you would square the numerator, over a squared minus y minus k squared over b squared equals 1. And that's probably what they want. You got to use that Greek letter. I couldn't tell you what it is. You know, wiki search for that, Wikipedia or something, if you're not sure, because you do have to type it. Well, I guess it gives you the panel on the right for what to submit. All right, so Jamie, you also sent over some WebAssign. You also sent over 10 and 11. I'm gonna go to 11 next because Niko also had that one.
Okay.
Let's see if we can figure this one out. Any questions on this one, guys, or is this one all good?
Makes sense.
Good, yeah.
Great. Okay, so this is 11 here. It says consider projectile launched. Okay. Now, if you've taken physics, some of these equations might look familiar. To begin a football game, a kicker kicks off from his team's 35-yard line, and the angle, so that's your theta. Your theta is 51, and your V0 is 88 feet per second. The height is assumed to be 0 because it's moved back. It's on the ground, I guess. You already answered this one, Niko, correctly, I think, for parts 1 and 2. Do you, let me see here. Yeah, so Jamie, your X here is going to be V0 88 cosine 51 times T, except it says right angles in radians, which means you have to convert your angle to radians. This means you have to multiply by pi over 180, and that's inside parentheses there.
Okay.
And then similarly, y is going to be h, which is 0. You wouldn't write that, but it would be 88 sine 51 times pi over 180 times t minus 16 t squared. All right. So that takes care of that. So the maximum height is going to be from this equation right here. You have to graph this equation and it will do something like that. And you just have to find that max there. So Niko, maybe you got, and you want the y value, because there's two values, there's the t and the y value. Not sure why yours is wrong, Niko.
Let me check again. Yeah, let me graph it again.
I'm gonna graph Jamie's here, and I'll snip one in if I need to. D1 times pi divided by 180 x minus 16x squared. Yeah, so I get a max height of 73.08 feet. Could you confirm that, Jamie?
Yeah, I'll plug it in.
Wait, did I use the right angle? Yeah, 51. Okay. The only difference on yours, Niko, is the 90, I guess.
Yeah, I typed my equation in wrong. There's parentheses issue, I think. So
Okay. Yeah, for
Yeah,
yours,
that
Niko, I
one-
get.
That
That's what I
one
get
works.
for Niko.
that's what I got too. Yeah. Yeah,
Okay.
that's correct.
So for the part C, where it says to find the horizontal distance that the kick travels, you actually need this t value right here first, which is not the one that you just found. You have to get you want to know where it hits the ground. So for Niko, I'll put a little n here, 4.37. And Jamie, yours, if I do it correctly, that's not the answer, by the way, that's just the time. In
Okay.
physics, you often need time. Yours is 4.27. So you take those time values and you put them back into the x equation. So yeah,
Got it.
well, you're obviously each of you get slightly different values. If you've got your calculators handy, your mode obviously needs to be in radian to do this, or if you want to use degrees, just use the 51. But let me know if either of you need me to confirm your answers. All right, if there's no questions on that, I'm gonna look at some other stuff here you guys sent over. Niko, you sent over like a question 3. Is that
Yeah.
look
on the
right?
quiz. Yeah.
Okay. It says find the equation of the line find the equation of the tangent line to the parabola at the given point. Okay. You guys aren't taking a calculus class by mistake here. This is odd. Okay, let me snip it in. So if you guys do take calculus, tangent lines are pretty straightforward, but this one is so there. If you were to graph this, y equals 1/3 x squared, there's the origin. It's got kind of this shape. Oh, it's on the other side. It's over. We live in the positive world, not the negative. So here's -2 4/3 roughly. So there's a line that only hits it in one spot. That's the tangent. So for a tangent line, for the equation of a tangent line, you almost always use what's called point slope form. You guys remember that from previous classes. And there's two things you need. The first is the slope, and the second is a point. So they give you the point. You're all squared away on that. Now your instructor had to give you some guidance about how to find a tangent line. There must be something like the tangent line goes through this point and something else, since you don't have calculus to be able to do this. Maybe that's the focus. Do you guys know? Remember from class? Like, does it have to go through this point here? Well, the focus isn't here, so this would be the directrix.
Yeah.
Jamie, do you remember?
I'm trying to think.
So what is the focus? Oh my gosh, we gotta look at this. So the I gotta go find those equations. So you got it here. 4p equals 1/3. Is that what you've got? Now let me go find the equation.
Yeah, I don't know. I don't think it's right, but
All right. So there's a really good Conic Sections reference equation sheet that I'll put into the chat here. I find this extremely useful. I don't know why they don't let you have this one. It's very compact and everything is nicely on there. So there is your reference sheet. We're doing the vertical axis for a parabola. So I'm going to snip that in here. So here it is. So that what it says here is that the directrix is, see, I still don't know how you would know this, but okay. So the you have to set your equation has to be in this form, which it kind of isn't. See how there's like a thing in front of the y. So if you move the y, it's really 3y equals x squared. So 4p equals 3, and that's how you got p equals 3/4 on this. And then it says, oh, the directrix is down here at k minus p. Y is 0 minus 3/4. K is 0 because there's nothing there with that. So negative 3/4, and it's right below the vertex. So this other point here is 0 comma minus 3/4, and then there's the other point. So we're going to find the slope between them. I hope this works. This doesn't feel like it's going to work. Minus 3/4 minus 4/3 over 0 minus a minus 2. So the numerator, if we make it 12, I don't feel like this is going to work. Minus 9, minus 16 over 12 over minus 2, minus 25 over 2. Yeah, that's not right. Well, wait, maybe it is. Maybe it is. Minus 25 over 12 over negative 2. So minus, well, it's positive 25 over 24. Is that even right? So the correct answer is actually the slope is, this is from calculus, it's 2/3 times negative 2. It's negative 4/3. I don't know how you're supposed to know that. So I know I'm sort of going off here on not really being helpful. You're somehow supposed to figure out the slope, and I don't know how to tell you to do it without calculus. It may be that your instructor gave you a formula or something, said, you know, this works for this. So I don't think I can be any more help on this problem. There's something about the point of interest and either the directrix or like maybe it's perpendicular. There's another possibility. Maybe you have to find the slope of this line and then it's perpendicular to that.
okay.
So I don't know, I'm not gonna be any more helpful in this because I don't actually know how you would do this without using calculus. So I apologize, but let's find some other stuff we can do. So let's see here. Jamie, you sent over some other problems here. 9, 10. We already did 10.
Yeah.
9. We need to do 9.
Yeah, that was one.
It's very similar to what we did here. So let me take a look here. So again, you may remember that circles are x minus h squared plus y minus k squared equals r squared. And that gives you some hope here. But the other thing that's really going to come in play is the sine squared alpha plus cosine squared alpha equals 1, which means you really need to solve each of these for cosine and sine. So the first one, x minus h over r equals cosine alpha. The second one is y minus k over r equals sine alpha. And then you square both sides.
Do you do those equations again?
Exactly. So you're gonna you plug, you know, each of them in, and then because you're adding, the order doesn't matter. So you can actually, you know, you can do cosine squared alpha plus sine squared alpha equals 1. But the final answer here is x minus h squared. Well, actually, let me take that back. It's r squared plus y minus k squared over r squared equals 1. But then you can clear the r squareds by multiplying everything by r squared on both sides of the equation.
Oh, because the circle. Okay, that makes sense.
Yep. Yeah. All right, I need just 30 seconds, guys, to just give me just a little short break here. I'll be right back.
Okay.
All right, I'm back. Niko, do you have some other stuff that we could look at?
Yeah, I have one more on that quiz. I'll send over.
All right, let me find another. Maybe there is a. No, calculus. Jamie, did you get this question on a similar quiz, the tangent line of the from a parabola?
Maybe. Let me pull out the quiz real quick.
So I do have an answer for that problem. It's quite complicated. I mean, but conceptually it's not. So here's what a parabola looks like. And if you want this point, there's a similar point over here, and you can actually fit a circle with these 2 points. This is not drawn very well. And there is a center somewhere. So if you recall from geometry, if you create a tangent to the center, like that, these meet at 90 degrees. So the solution is to somehow figure out the equation of this circle to get the center, find the slope from these 2 points, which is not horizontal, it's just drawn that way, and then take the opposite reciprocal to find that for it. And there's some quadratic formula stuff going on here too. You got a really interesting teacher to thinks that's an interesting thing to work on. I would just ask, maybe there's a shortcut there that wasn't, maybe there was a shortcut that was missed in the notes or something for it.
Wait, what?
Okay.
Can I see the problem real quick?
Yes, the problem it is right here. Find the equation of the tangent.
Oh, okay. Yeah, I have it down here. So she gave us like the base equation for it, which was 4p times y minus k equals x minus h squared, right?
Yep, we got that here.
Right there. So then it gives you what are the 2 points there?
Well, you get this, you get the -2 4/3 is the point.
Is that the center?
No, it's just a
No.
random point on the
Oh, just a point.
That's the point on there. This thing has a vertex at 0, 0.
Okay.
Whether that matters. or not.
Oh, and then you have to solve for 4p.
So we did that. P is 4/3.
Yeah.
Okay.
And then after that, you plug in. Where did I plug? Shit. I do. Okay. From here, I got the rest of it wrong. That's
Okay.
where I'm lost.
Well, I would guess I would go ask your instructor. It is something here for this, but we probably can't do any more on this. So let's take a look at this other quiz question, which is quite awful. So it's true that planets have elliptical orbits, even the Earth's, but the 2 foci are really close together. So it's approximately a circle. But the larger planets, I don't even know if Pluto's a planet anymore. You might ask your instructor. So the furthest Pluto gets from the sun is 7.4 billion kilometers. Closest it gets to the sun is 4.4 billion. The picture here is quite good. It's like you're saying the sun is right there. So the closest it gets is 4.4 and the furthest is 7.4. And we know that the sun is one of the foci. So there's another foci somewhere over here. So the total distance is 11.8. Cut that in half. 5.9. So if you want like better numbers, there is, if we need them. Yeah, there's another 1.5 here. If we need that. And then no. Is that right? No. This whole thing is 7.4. Okay, so the whole thing is 7.4 plus that 11.8. Okay, so that's to the center there. All right. So and then we got this right here. Okay. And then we need the equation of the ellipse. So I'm going to go back to that reference sheet that I sent you guys and pull up. Where'd it go? find that reference sheet. There it is. Okay, so this one has a horizontal major axis. So you gotta have your equations here to be able to do this. So there's 5 things you gotta find here: H, K, which you know are both 0, and then A, B, and C. And somehow you guys, or you wrote this A minus C equals 7.4.
Yeah, that was, I wrote under, it's supposed to be A plus C equals 7.4. I just wrote it wrong.
Yes, there's a couple of these. There's A squared equals B squared plus C squared in this one, which is another potentially. And yeah, so when from this equation set over here, yeah, A plus C is supposed to equal 7.4, because you're actually supposed to write 2 equations here. And then A minus C is going to equal what, 4.4?
Yeah.
Something like that. So then you get 2A equals 11.8 and A equals 5.9. And then you can find C. C is 1.5. And then you can find B from that relationship up there. A squared equals B squared plus C squared. So B is going to equal the square root of 5.9 squared minus 1.5 squared square rooted. So when you get that number, you plop that into this equation right here, and you're done with part A. Any questions on that?
No.
Okay. The eccentricity, you gotta have the formulas. Like, there's no way to know this. And I don't even know what it means, but guy works for me. He's really into this stuff with planets and astronomy, and I'm sure it has meaning to him. But for the rest of us, eccentricity is just C divided by A. So you need like all these, whether you got a parabola, an ellipse, hyperbola, it's all about finding these values. All right, so hopefully that helps with that. Jamie, I'm going to go back and look at your WebAssign here. I see question 8, possibly.
Yep.
Okay. Niko, do you have some other stuff you want to queue up for us?
Yeah.
Look. So a couple things, as you guys take more math, if you do, there are always better graphing tools. So Desmos is great for rectangular, right? X, Y, that's rectangular. They also have what's called a parametric graphing tool, which obviously I'm going to show you this by hand, but obviously like the picture is really helpful. Like go find that one. And then there's one for polar equations, polar Desmos, and there's other ones. Okay. The visual is really helpful here. So the only way to do this is to make a table. Was there a question there? I'm sorry if I interrupted. So what I notice and I don't, well, you generally start with T and you start at 0, and then you need your X, which is e to the 2t, and your Y, which is 2e to the t. What you do not do is solve it for, like, put it into rectangular form. You don't have to, is I guess the point. So the first one is e to the 0, that's 1, and Y is also e to 0, so it's 2. So you're looking for the point 1, 2. So like that's looking pretty solid, and that's probably it, actually. So that's probably not. But let's just go with one more point. Like 1, that becomes e squared, and then 2e. So e squared's about 8-ish, 2e is about 6-ish. And that kind of is right there, because the thing that you're actually supposed to show here is the trajectory. You're supposed to show the direction that it's traveling when you do that.
Gotcha. Okay.
Now part B is to eliminate the parameter. What you have there is probably correct. It probably just wants you to simplify it a little bit more. So T, Okay, so so this is x equals e to the 2t. And then y equals 2e to the t. So the choice is to solve for t so that you can put it in there. Okay. I'm going to show it a slightly different way. You can actually write this e to the 2t as e to the t squared.
Mhm.
You see, do you
Yep.
believe me? Do you remember that? Okay. Now, why is that useful? Well, you actually can substitute in for e to the t instead of t. Like I know generally you would solve for t, and that's what probably you'll do on a test, but I want you to see this
Oh.
because if you take a square root of both sides, square root of x equals e to the t. So e to the t is really
Two
square root of
square.
x, 2 square root x, and you look at that
Okay.
graph, you're like, oh yeah, it looks like a square root.
Okay.
That's kind of your test prep kind of approach.
Mhm.
I don't know what part C is. What does that mean?
That's just, she like taught us a special way to write domain or range or whatever, but I
Oh,
can
oh,
do
I
it
see.
now.
I see. So this is bracket maybe, but it goes from 0 to infinity. I mean, you get that from the graph there. So infinity always has that. And I guess it's defined at 0. Yeah, I guess it does work.
Yeah.
That's your domain. That's the interval notation, and that's the one that you're going to see more often as you take more classes. All right. Niko, did you send something else over for us to look at?
I think so. Yeah, I sent another one.
Okay, there it is. Ah, what are these? These are super boring. I don't know why this is taught in your guys' class. I mean, the conic sections. I mean, they're just they always teach them, and I don't know when you say like, hey, you're going to use this again. Really don't. So this is a hyperbola, and you got to know all the equations. Like you can't do this if you don't know all the equations for hyperbola. So I'm going to snip them in, and like I think you're supposed to know these for your exam. It's really tough.
Mhm.
Because you're supposed to know all these. Now, if you're really paying attention, you can pattern like, oh yeah, like the center is always the same and the vertices are flipped. Same with the foci and same with the asymptotic equation. Here, you got to decide, well, am I vertical or am I transverse? And I like to use the vertices to be able to do that. And so because it looks more like this one, I'm going to suggest that this is a vertical one. And furthermore, we know that h is 0 because h is the first coordinate of it. I'm using that plus or minus to decide there also. Looks like a is 4. Is that okay? We still need k, b, and c. All right, so to find the other ones, I guess we're going to use the asymptotic equation. The asymptotic equation, it's kind of in this form right here. It looks to me like a over b equals 2. And since we know a is 4, we can say that b is 2. Excuse me. We also know that k must be 0 because there's nothing in front here. And then to find c, and this is different than an ellipse. An ellipse was a squared equals b squared plus c squared, I think. This one's different. C squared equals a squared plus b squared. And the a's and b's are in different spots on the equations also. So you really got to pay attention to all this. So your c is the square root of 4 squared plus 2 squared. It's not the worst. I mean, it's the square root of 20. And then you can write your equation. So your equation is y squared over a squared minus x squared over 2 squared equals 1. Actually, you don't even need c to write the equation. So You may, I mean, WebAssign should take this, but you could also make it like this. Jamie, do you have a similar problem to this that you know, where maybe your numbers are, you know, different than 4 and 2? This is number 8.
Mine happened to actually be the exact, wait, number 8.
Maybe not. Maybe I missed
Actually,
up there.
yeah, my numbers were the exact same, which is
Okay.
lucky.
4. This is 4. 4, not 8. Like I can't remember if we did like law of sines and cosines where you're finding angles in the triangle. I like to organize all of the conic sections into a list of letters and numbers. And then you're just like, the game is get the numbers to put them back in the equation or use the equation to get to the numbers to get something else. It's very heavy on memorization. Let me look through these emails one more time and see if there's some other stuff. Niko, did you have your number 8? Was your number 8 similar enough that you could figure out how to manipulate
Number
it?
it was the exact same. So
Okay. Said your test is on Wednesday. Does that mean you guys have class tomorrow or did you have it today?
We have class tomorrow as like a review, so we'll be able to ask about that one question on the test.
Yeah. You know, the way my recommendation would be to you know, first ask, hey, is this going to be on the test? But if they won't tell you that, then I guess go through it. There's a lot of work here to do this, so be prepared to kind of write it down. I had this really interesting instructor in college. I was taking an electrical engineering class, and he would come in every day, and he would say, "What is your first question?" And it could literally be on anything. You could ask him about school, his political affiliations. Like he was like, I don't know, that was just his style. And whenever you ran out of questions, that's when he would start doing the lecture. It was really one of the oddest things I've ever seen, but it fit his personality. He was very old and very you know, set in his ways. No one was going to tell him to do it any different. What else can we work on today, guys?
Let's see. That might be everything I have, I guess. Do you have any suggestions for like noticing things on the test? Like earlier when we did the identities or whatever with the sines and cosines. Like, is there anything to look for when you start a problem?
Yeah, so math problems are generally forwards or backwards. And a forwards question is I give you the equation of a conic section and I tell you to determine, you know, A, B, C, H, K. And the backwards is I give you, you know, given A, B, C, or the information to find them, like we did in that problem with the orbits. This one right here. This is a going backwards question. And then you're writing the equation from that. So like what could you do to study it? It would be like, well, let's just say you knew the answer to this, you knew the equation, which I never wrote down, but let's just like from the equation, can you get back to this potentially?
Okay.
This is very specific though. I mean, that's not a great example of it. Does you want to think about like things that your teacher says, because you probably like in class, they'll say like, this is really important. And, or, you know, make sure you study this. And then all of a sudden it's on there. Like a symbolic question like this is great, but you're probably not going to get this. You're probably going to be asked to, let me see if I can, I had a student last night that actually had some similar problems. So let me see if I can pull up their thing real quick. Are you doing any polar equations?
Are we, Nico?
I don't think so. It's on.
I don't think so either, yeah.
All right, well, it's related. It's really close in here, but it was like, yeah, well, it's not relevant. So this isn't relevant either. I would ask, like, there's three types of conic sections. There's parabolas. There's circles. I'm sorry, there's ellipses. And then there's hyperbolas. There's also circles. And there's kind of a question at the bottom of your quiz, Niko, that we didn't do, but it was like, determine what it is. Like which conic section it is. I guess I would maybe want to know, like, how many of each type. Like, are you going to get one of each? And with each type, there's an X and a Y equation. You know, I've seen these exams where they just give you 6 equations, not in standard form. You have to find all of the parts of each, all the A, B, C's, H, and K's. I am struggling here a little bit to give you some words of wisdom. There is this kind of useful thing at the bottom of the reference sheet where it says, here's how you classify your conic section when it's in the standard form. But that would only apply to that like one problem I saw in your quiz, Niko, that you were kind of looking.
Like if we had to determine which one it was, kind of thing.
Yeah. If you're still struggling with like which is a X and a Y ellipse, you know, long versus short, I would go to Desmos and just graph them until you kind of understand what
Just
changes it. Like what pulls it left and right, up and down.
Mhm.
And you can actually do that by just typing in X minus H squared over A squared, and you just create sliders for like H and A, and you can set them as nice values to start, but then you can maybe change one or the other to see how it manipulates what's going on there.
Okay.
Sorry, I don't have a lot of good advice in this. I wish there was an easier way to get through this part of the course.
All good.
Niko, any last concerns, questions?
Yeah, one last question. On
Sure.
number 4 was, let's go back to it. It was the asymptote. Did you just plug in like the A over B from that asymptote, or did you plug it into the whole equation?
Two is literally A over B. That is A over
Okay.
B. And I already knew that A was 4 from the vertices.
Okay, so you just take it from there.
Yeah, and then I just quickly solved for B by, you know, dividing by 2. But yeah, I mean, you go with the one that kind of gives you the most information. It happened to be vertices, because if you started out with A over B equals 2, that doesn't really help you because it's one equation with 2 unknowns. But the vertices let us right down to getting A. There's also a few things in here, Jamie, like that, like built-in checks, like C has to be greater than A, and C has to be greater than B in a hyperbola.
Hyperbola.
Similarly, in an ellipse, because the ellipse is like this, A squared equals B squared. You know, A has to be bigger than B, and A has to be bigger than C. Like those are some things that they don't really tell you, but they do help you identify if you got the equation correct or not.
Okay.
All right, guys. Well, thank you so much for scheduling. If there's nothing else, you know, I hope your quiz test goes well, and you look forward to helping you again if you got a final or something coming up. But
Thank you.
You're welcome as always. I'll send you the notes here shortly, and I'll see you next time.
All right. Thank you.
Bye now.